In this tutorial, we're going to look at the transient keyword, which is used when you're serializing objects. And we're going to take a look at a few other things in the context of serialization, just to wrap the subject up from the previous two tutorials. So I've got the code here from the last two tutorials on serialization, and I've changed write objects so that we're just writing one object to our file, and that's test.ser, I've called it. And we've also got read objects, which is reading that one object back from the serialized file. The first thing I want to show you is a transient keyword. Let's take a look at the object that we're actually writing, and that's this person object here. So we've got a toString method, and that just allows us to output the person object with system.out.println. And we've also got two fields here, ID and name. And we've got this constructor that allows us to construct the person object. So at the moment now I can run write objects. Let's run that. And it writes the objects to this test.ser. You might have to right click and refresh your project if you want to see a file that you're writing to your project directory. You might have to go to refresh down here, this one. And then we've got read objects here, which if I run that, it reads the object from the file and it outputs the object with system.out.println. Now, what you don't want to do is you don't want to serialize more fields than you actually have to, because that's going to be inefficient. And sometimes there are going to be fields in your object that you just can't serialize, or if you did serialize it, it'd be pretty weird. So an example might be if you're using threads, which I discuss in my multi-threading tutorial. You don't want to try to serialize a lock or something like that. So certain kinds of fields you don't need to serialize, or it's just not useful to serialize them. And you can prevent fields being serialized using the transient keyword, which is pretty simple. So let's supposing, for example, that we've decided we don't need to serialize this ID for some reason. Normally you would want to serialize an ID, but just to have an example, let's change this to private transient int ID. And like all the other keywords in Java, transient has a lowercase t. Now we'll run write objects again. So that's going to serialize this, an object of this person class. We'll run that. And then we'll run read objects here. And now we can see that the ID is 0 instead of 7, which it was previously, because in write objects here, I'm constructing the person with an ID of 7. And what's happening now is that because I've marked this ID as transient, it's not being serialized. And the reason it's 0 is because fields like this in Java are initialized to a default value. That's not true of local variables within your methods. But your top level fields in your class will be given a default value to start with, and for integers that's going to be 0. So that's why this is set at 0. It hasn't been serialized. So that's the transient keyword. It's pretty simple. You just use it to prevent things from being serialized. Now something someone kindly pointed out to me, which I kind of forgotten somehow, was that here I'm using one of these Java 7 style try with resources blocks to construct my file input stream and object input stream here. And the try with resources, this kind of style of try catch, will automatically call a close method on these objects if they implement the auto closable interface, which they do in Java 7. But it's possible to make this quite a lot tidier by nesting our constructors. So what we really need here is we need this object input stream, because we're using that down here. We don't really need the handle to this file input stream. And what I can do is object input stream needs this file input stream here, but I can just take this bit where we actually construct the file input stream and paste it right into the constructor argument of object input stream, and then I don't need this stuff here. We can get rid of that. and that's a bit tidier. I'd sort of started avoiding doing things like this because I don't like to see things nested too much. It makes it a little bit harder to debug if things go wrong. But in this case, we know it's working. Anyway, we've already used this, and this does look a bit more elegant, I must admit. Let's change write objects too. So I'm just going to construct this new file output stream right in the actual constructor brackets of object output stream, and then we can get rid of this. And let's check that it works as before. So I'll go and minimize the editor, and we'll run write objects here and read objects, and we get the same result as before. We've successfully serialized and deserialized the object there. Another thing that's worth mentioning is the behavior of static fields under serialization. Let's go to person here, and let's give person a static field. Let's say something like private static int count, whatever that is going to be. And I'll provide a get and set method for count. Let's see if we can get the IDE to do that automatically. So I'll right click here and go to source, generate getters and setters. I'm not sure if I've actually tried this before, but yeah, it seems to work. We select count, click OK. And of course our getters and setters are going to be static because we only need to have static methods to access a static field. So these methods are associated with the class, not with individual objects. And so is this field here. And that's the point of static fields, you may recall, that there isn't going to be one bit of data for every object now. There's only going to be one actual static int count here for all objects, and every object sees the same field here. And if you think about it, that means it wouldn't make sense to serialize count. So to demonstrate that, let's go to write objects, and let's say here person.set count, and I'll set it to 88 or something. And let's also change the toString method. Let's just check this warning here. So it's saying the static method set count should be accessed in a static way. Yeah, that's something I've done wrong. Because set count, it belongs to the class, we should use the class to access it. It's a static method, so we should do it like this rather than using a particular object. And we're setting that for all objects of that class because there's only one field. I can also make toString output this field as well. So let's go to person here. Let's delete the existing toString, and I'm going to right click and go to source, generate toString. Well, it's not giving us the option to add count in there, so I'll add it in manually. I guess it's not really normal to have a static field in a toString method. What I can do is I can just add it in. So let's say here at the end, maybe plus, in fact I could add some text here, count is, and then we can add on count. Now let's see what happens when I serialize this object and deserialize it. So I'm going to run write objects here, and I'm going to run read objects, and we see that count is 0. And again, because count is a kind of class level field, it's at the top here. It's going to have a default value which is going to be 0. But you'll notice that I set count, and yet count was not serialized and deserialized, and in fact static fields are not serialized, and the reason for that is there's no need to serialize a static field. It wouldn't make sense to be saving a value of that field for every object because the field belongs to the class, not to individual objects, so you'd just be saving the same data over and over again. If you've got a field that's static and you think it should be serialized, then you probably want a non-static field in there. Okay, so I think there's a couple of more things that I just want to cover here. Yeah, so let's take a look at this serial version UID. I don't think I covered this in previous tutorials. If I did, then my apologies, but I'm just going to go through it here because I don't think I've gone through it in much detail yet. If you create a a class which is serializable. In other words, it implements a serializable interface which has no methods in it. It's just kind of like a flag saying that this is serializable. Then Eclipse will give you this warning saying the class does not declare a static final serial version UID field of type long, which is quite annoying, to be honest, because we don't really often need to use this field. But let's click on that warning and go to add generated serial version UID. And I say yes, that I want to save this and get rid of these superfluous comments. What does this actually do? Well, serialization will work just fine without that. There was only a warning there wasn't an error. So now this is just working as it always has. I can write objects and read them, and we get stuff down here. But watch what happens if I write an object with one serial version UID, and then I change the ID. Let's change this to 1. You'll notice there's a capital L on the end there, and that's that kind of casts what would otherwise be by default an integer to type long. And so we've actually changed the ID here, and now I'm going to run read objects, and what we get is we get this error. It's an invalid class exception, which you can catch if you want to. It's a runtime error, so we're not forced to catch it, but you can catch it if you want to. When you read your objects back, you could catch it down here by adding a catch invalid class exception. So what this is purely what it appears to be, really. It's just a check to make sure that you're deserializing with the same version of the class that you serialized with. So it's just a way of preventing people deserializing objects when you've actually changed the class. If you change the class significantly to the point where you don't want people to be able to deserialize objects using the new version of your class, which were previously serialized with the old version of your class, then you can just change the ID up here, and it will no longer be possible to deserialize using this new class. Not something that's terribly useful most of the time. If we change the ID back to what it was originally, we can now run read objects, and it will work fine as before. So it's just a little check on making sure you're using the same version of the class to deserialize that you originally serialized with. And the last thing I want to mention is the behavior of constructors with serialization. So we've got a constructor here that we're using to construct this person object right here. Let's create a default constructor as well. Let's say public person. I don't think we're really going to use this, but I'll bung one in anyway. And I'm going to say sysout, let's say default constructor. And here I'm going to put a sysout control space and 2 argument constructor. Okay, constructor. There we go. So let's run write objects here. So remember, write objects is actually creating a person using the 2 argument constructor. So let's run this, and it says down here writing objects. That's coming from up here, and then 2 argument constructor, because of course we're running that constructor. And you have to run some constructor to construct an object. If you see new somewhere in your code anywhere, then that is going to invoke a constructor. But now if we run read objects here, let's run this, you'll notice that no constructor is run. And that makes sense, again, if you think about it. When you deserialize an object, you don't want to run any of the constructors. All you want to do is you want to get an object that has the field set to whatever they were when you originally serialized the object. So this is one situation where you're getting an object without running any constructor at all. So whatever you put in your constructors, it's not going to make a difference when you deserialize stuff, because these fields are just going to be restored to what they were when you originally serialized the object. So deserializing doesn't run any constructors, which is something just to be aware of, really, in case you've done a massive load of initialization in your constructors. And again, that makes sense if you think about it. There's no reason why you would want to run a constructor when you deserialize an object normally. Okay, so that's it for this tutorial. In the next tutorial, we're going to look, I think, at the difference between passing by value and passing by reference. And in fact, this is a tutorial that several people have asked me to make, and Java only implements passing by value. But we're going to look at what that actually is, what those terms mean. And we're going to look at some little gotchas that might catch you out with Java. So that's for next time. And until then, happy coding.